For this week's Cloud S.L.A.W, it's kind of exciting. We've got a lab on a service that was just released 4 or 5 days ago. One of my martial arts masters once said, timing is everything. Or maybe it was in timing there is everything. And maybe I saw that in a movie or it was in an episode in that old show American Ninja for those of you that were around in the 80s. But it definitely wasn't a Yoda quote because I know those ones really cold. And anyway, in our last lab, we learned how to make an S3 bucket public using a bucket policy. And we touched bucket policies once before. If you recall, we could make it public on the internet by opening up to an IP address, or we could just make it available to any AWS principal, which opens it up to other access from other AWS accounts and potentially other sources. Now, literally the day I released that lab, AWS released a long anticipated feature called Resource Control Policies, or RCPs. This was, or well, is since it just happened, incredibly exciting for us cloud security pros because it addressed some of the thorniest issues around managing consistent access at scale. One of the core concepts we're building towards with all of our focus on AWS organizations, IAM, service control policies, and even VPC endpoints is called the data perimeter. We aren't quite where I want us to be to go too in-depth on what that is, but after nearly a year of these labs, you have an incredibly sound foundation for when we start learning the in-depth implementation. Conceptually, a data perimeter is the combination of various cloud security controls used to ensure that you have effective control over how and where your cloud data is accessed. You know, network perimeters it's just easy to plop some firewalls in place, write some rules around sources and destinations, and control that level of your network perimeter. But enterprise scale cloud data perimeters are hard. You have to control access to data at both the network and the IAM levels and do so consistently in heterogeneous environments where you don't own the backbone. You don't own that cloud service provider's backbone. Everything is managed over the internet because we're in public cloud and we're in these multi-tenant and multi-account environments where we actually do need to share data across different silos for legitimate business purposes. Resource control policies, RCPs, are the missing link that provides centralized rules for consistent control of resource sharing. RCPs are like service control policies and permission boundaries. They are the basis for what we call security invariance. Those are rules that are consistently enforced without the need for exceptions and can be enforced broadly at scale. Here's how RCPs work. And explaining this is going to be really simple because we just covered bucket policies and we previously covered service control policies. An RCP is like a service control policy combined with a resource-based policy. So, like a service control policy, it doesn't grant permissions, it restricts the maximum allowable permissions. Even if an RCP has allow statements in it, the resources associated with the policy, the resource-based policy, like the bucket policy that's directly on that resource, also has to allow access. So again, it doesn't give you permissions, it just takes them away. And if you recall, like with an SCP, you still need those allow statements because otherwise an implicit deny would kind of like block all access. And what's nice is RCPs also use the same policy language we've already been using for everything else. Now, another interesting piece, I'm going to show a diagram in a moment, is that RCPs are evaluated even before SCPs, the service control policies. And why is this? Well, if you recall, resources may allow direct access that's not associated with an API call for some resource types. So like those S3 buckets can be accessed via a URL. So it makes sense that we need to evaluate what are the rules around that resource without getting hung up on what are the rules around the identities accessing that resource using APIs. Because remember, to use an API, you have to have an identity involved. For example, you've seen that I share all of our CloudFormation templates by just giving you the URL to the S3 bucket where I host them as we build out our labs. And an SCP couldn't restrict this access since it's not associated with an IAM principal or a regular API call. And so that's why it's important for the resource control policies to be evaluated first. As with all other policy types, any Explicit deny, any written out deny statement in any policy anywhere will block access across that policy evaluation logic. But as we discussed last week, an allow in a resource-based policy can skip back past implicit denies. And as a reminder, an implicit deny is that all these policies are default deny. So it's always deny unless you have an allow statement to allow something. And you have to have allow statements in every single policy type, the service control policy, the identity-based policy, and the permission boundary for somebody to do something. But because a resource might be evaluated before those implicit denies are evaluated, that's why we have to make sure that that any explicit deny will override everything else. RCPs give us a top-down way to manage that different evaluation flow. If you block access in an RCP, the implicit denies, the explicit allows, none of those matter. That deny statement is evaluated first. Like a service control policy, RCPs can apply to accounts or organizational units. They also don't work on the org management account, but you shouldn't be sharing stuff out of your S3 bucket from that org management account. Remember, you really want to restrict who uses that org management account. Another feature that was released last week is called Assume Root. And you could imagine if you had admin privileges in that management account, that gives you some pretty powerful capabilities. And we're going to get to that one later. But really, minimize use of that org management account. Use that delegated administration. That's how we've been building all of these labs from the start. Now, by default, AWS applies and allow all policy at every level when you turn on the resource control policies. And this is just like those service control policies because the implicit deny in an RCP could block all access to all resources in your entire organization if you applied at too high of a level. So this prevents those catastrophic failures. Remember, again, I know it's confused, but any deny statements will override any allow statements. But if you don't have those allow statements, that's an implicit deny, and then everything gets blocked. RCPs also support conditions, and some of these, like only allow encrypted S3 communications, are going to be specific to a service and different than what we use in service control policies. That'll make sense when you look at it. Look, here's a quick review of the updated policy evaluation logic. So they just put out this new diagram. And as you can see here, any deny anywhere overrides any allow statements anywhere else. It's just bam, denied. So if there's a deny statement in the RCP, the SCP, the identity-based policy, the service control policy, the bucket policy, it doesn't matter. Any of those denies will override everything else. Then the resource control policies are evaluated before anything else. As I mentioned, this is to make sure that it blocks any access, make sure that you are allowed to have access and it blocks any access no matter what happens at any of the identity layers, because somebody coming in direct from a URL, it's not even going to have the ability to be evaluated by a lot of these other ones. Then we get back to the service control policies, the actual resource policies itself. So this looks complicated, but the flow is very similar to what we covered before, all the way down to individual session policies. The key thing to remember here is that these resource control policies can work at a very high level. They can apply to resources throughout the rest of the organization, and they're evaluated very, very early. RCPs only work for a subset of AWS services. There's some important ones. Obviously, Amazon S3, and we've talked about it. That's what we're going to use today. Also, the security token service. If you recall, that's the thing we need to create sessions and to assume roles. And why would that be in here as a resource-based policy? Well, you can set rules now that say things like only entities from my AWS organization are allowed to assume roles, or maybe just particular roles. So we can block cross-organization and cross-account access and abuse of our roles. It's a really powerful feature, again, beyond what we're going to get into today, but we will be getting into that one later. Amazon's key management service, which is for encryption keys, simple queue service. That might seem a weird one to be prioritized, but SQS is a really commonly used way to share application logic between accounts and between services. So this helps you lock those in to your account and your organization. So you can use it to like send messages between microservices in different places. And you know that nobody else can add themselves to that. It would just be locked down through an RCP to just your organization. And same thing for Amazon Secrets Manager. So what are some use cases for RCPs? Well, essentially is that the value of these is we can enforce rules throughout our organization. You could do all of this with individual resource policies. This allows me as a central like security administrator or central operations administrator, to control the maximum amount of sharing in my organization. And that's a big deal. I'm not teaching you guys how to manage one AWS account. I am teaching you how to manage large-scale enterprise environments. And resource control policies are now a really critical linchpin to help us manage the sharing we have across those resources, and especially those S3 ones, because that's where we have some of our bigger issues. Some examples are you can allow someone to assume a role, but only if it came from your IAM identity center, or allow principals in your organization and only your organization to access encryption keys. That means even if somebody tries to share a key with another organization, they won't be able to. Or the one that we're going to use today, which is going to say, only allow people in my organization access to an S3 bucket tagged as sensitive. Well, that's a really cool one. It's a lot of fun, and it aligns really well with the labs we're doing right now on data security because we're spending all of this time within S3. So let's go get to it. The flow for our lab this week is we're going to log in. We're going to go back to our management account. Remember, that should be called S.L.A.W. We're going to pull our organization's ID so that we've got that ready. We're going to enable resource control policies. We're going to build a new one, and that's going to be one that's just based off of one of my templates. Then we're going to apply that to our workloads group. And I'll walk over the individual details about that. So it's going to go to our workloads organizational unit. It won't do anything yet because we don't have any resources that are going to meet the requirements of that resource control policy. But that's something that we will test out in a lab that's coming up really soon. So this is just going to set us up for that. All right. So start by going into your sign-in portal and go to Cloud S.L.A.W. and Administrator Access. So this is our org management account. And from within here, we're going to go into organizations. Now, a big note, you'll notice that the user interface is looking a bit different than it has in the past. There's been some changes within AWS. And don't worry about my bill. I'm running some stuff in here that none of you are running to get it ready for Amazon reInvent this year. But where things are in the console is largely the same, and you may or may not see this depending on when it rolls out to your account. All right, with that said, let's go to AWS organizations. And within organizations, once it pops up here, and you can see this looks the same. So this part of the UX hasn't changed yet. We're going to go to policies, and we'll go to resource control policies. You see right now, those are disabled, and we only are using service control policies. But we're going to start, and we'll go to resource control policies. Zoom out again, and enable resource control policies. Now, when I ran this in my test environment, it took a couple of minutes to get up and running. So I'm going to go ahead and pause the video while we wait for that. Well, in this account, that actually took less than a minute. And you can see that we have our RCP full AWS access in here, which allows everything. Remember, because of implicit denies, that would actually, if we didn't have that in place, then nobody could access any resources, well, S3, SQS, and the other services covered in our account. Okay. Now, we want to create a policy, but before we do that, I want to go ahead and copy out my organization ID. So hit copy there, and then pull out from the blog post our template. Within our template, you'll see this section here where it says my org ID, and paste your org ID into there. Now, just to walk through this quickly, let me make that text a little bit bigger since I've got some screen real estate here. This is going to deny access to sensitive data. It's denying from any principal, anything in S3, on any resources in S3, if, and this is where the logic comes in. So it's this and this and this. So these are all, if the string exists, that is a particular resource tag. And you need this because if you just did string equals and that tag isn't there, then it could actually break. So if that string exists, and in this case, it is a tag, and the key is classification, and the value is sensitive. So if something is tagged with a classification of sensitive, and then we get into our negative logic, and it is being accessed from outside our organization, that's what that not equals is. So if it's from outside of our organization and it's from basically this has to do with covering for AWS if it's an AWS service. And we have to be able to allow the AWS service so that it is able to gain access to this. Okay, I had to actually pause because I was going to give you the wrong advice. It turns out that I have to update this, and don't worry, the version you will see will absolutely be updated. Let me go ahead. I'm going to actually prettify this formatting. But the problem is that shouldn't have been a bool of if it's an AWS service true, because that would block it if it's an AWS service. What it should have been is bool if exists. So if this is coming from an AWS service, but it's and it's not coming from an AWS service, it's going to go ahead and block it. So this logic here will allow an AWS service to go ahead and access that resource. And that's going to make sure some internal things don't break. So give me 1 sec. Let me clean this up. Now it's all pretty with all the characters in the right place. So let's review that logic. If it's tagged as sensitive and it's not from our organization and it's not from an AWS service, so that means it's somebody accessing it directly from another environment, it's going to go ahead and deny. So that's that logic here. And let's go ahead. We have our org ID in there. We're ready to go. So I'm going to copy all of this out, and I'm going to go to create policy. For this policy, let's just call it S3 sensitive or S3 classified sensitive. That's a good name for it. We'll put a description in. If bucket is classified sensitive, disallow access. All right. And then we'll go down to the bottom here and we can just paste it in. Make sure there's no errors here. Good. Oh, we do have an error here. Let's see what that warning is. It says related service principal missing the condition key. Give me 1 sec to run that down. Okay, when I click on the warning at the bottom there, it's just telling us that it is missing the bool if exists. We actually do have that covered. So we have our bool if exists. Now it says it should be true, but remember, this is a deny policy. So our logic is going to be a little bit different here. So ignore the warning that you see there. The policy as we've written here should work fine. And if not, you know what? We're going to fix that in a future lab. But this looks correct. And this actually it's a modified version of one that was in the official RCP documentation. So I feel like I'm on good ground here. And then we'll go ahead and create the policy. Okay, so now we have our RCP policy, the S3 classified sensitive. What we need to do is apply that to our accounts. So if we click over to AWS Accounts tab, and the one we're going to put this on is our workloads. And we're going to put this onto production. So let me click on production. And if we go to policies, you see that we now have resource control policies at the top. And you can see we have that full access. It's in the root, it's in the organizational unit, and it's attached directly to this individual, to any of the every resource here. What we want to do is attach. And we're going to go with our S3 classified sensitive and attach that policy. And that's it. So if I actually click back on my prod and go to policies, you can see that my prod organizational unit, and thus any of the accounts that's in here within prod, is going to have that S3 classified sensitive, and only in this area. Okay, I know it doesn't seem like we did a lot there, but we actually did. And we're going to get to test this out later. As with a bunch of these labs, like, we're really laying the groundwork. And don't worry, it won't be very long. We're going to run through a few different scenarios and see how all these overlapping resource-based policies work. And as a key thing to remember, just because you have like an allow all policy in an RCP doesn't give anybody access to anything. That bucket policy, that STS policy, whatever it is, has to also allow access. This is just that security blanket, which is how I described service control policies. That's it. Have a great week.